Hi everyone, let's do a second simplifying problem. Let's simplify this expression in x. Now, if I were to ask you right now, what is the value of this when x equals 3? You might be going, are you punking me? Are you kidding me? No, simplify the expression and you can do it quickly. All right, again, non-positive exponents are not allowed in the final expression. Now, first of all, we might want to express these factors in the top and the bottom as nice powers of x. So for example, x is going to be x to the first, all right? The square root of x is going to be x to the 1/2. Down here, we have x to the 7/2. And what is x to the 0? X to the 0 is 1. Although 0 to the 0 is controversial. And while we're at it, if you look at this original expression, we might want to consider the restrictions. What are the restrictions on x right now? Can x be positive? Looks good. Square root of a positive, the square root of a positive is fine. Yeah, positive values for x look good right now. What about 0? 0 to the 7/2. For example, the square root of 0 is 0. That's going to be no good. So 0 will be no good for x. What about negative? Square root of a negative number, no good. Either here or, as it turns out, the x to the 7/2 would have a problem with that also. So x cannot be negative, which means that we need x to be positive in order for this expression to keep it real. The restriction is going to be x has to be positive. Okay. Once again, x is x to the first. The square root of x is x to the 1/2. X to the 7/2 copies over. X to the 0 is 1. And we can ignore this at this point. Now, up here, how do you multiply powers of x? To multiply powers of x, you do what to the exponents? You add them. If you wish, you could do this work on the side. What is 1 plus 1/2? That's 2/2 plus 1/2, right? 1 is 2/2. 2/2 plus 1/2 is 3/2. So the exponent here is 3/2. Again, I do recommend side work instead of trying to micromanage over here. Do side work like this if you have to. We have x to the 3/2 over x to the 7/2. I'm ignoring the hidden restrictions for now. When you divide powers of x, what do you do to the exponents? That's rule 2 over here. When you divide powers of x, you subtract the exponents. What's 3/2 minus 7/2? That's going to be negative 4/2, also known as negative 2. It's got to be in this order. 3/2 minus 7/2 is negative 4/2. Okay, right? 3/2 minus 7/2 is going to be negative 4/2. Okay. Although do side work. Don't micromanage it. All right. I note here that the hidden restriction x being positive, it turns out that when you perform this division, that's when you hide the restriction, though it's not always clear. So I would say consider the restrictions either at the very beginning or consider the issue at the end. Okay, but anyway, we end up with x to the negative 2. 3/2 minus 7/2 is basically negative 2. We have x to the negative 2. Now, we're not done yet. We're not done yet, all right? X to the negative 2, that looks nice, but remember, non-positive exponents are not allowed. Non-positive exponents are not allowed. Negative exponents are not allowed in your final answer, right? What is x to the negative 2? Look at number 7, law number 7 in reverse. X to the negative 2 is what? It's going to be 1 over x squared. Where, again, x is restricted to be positive. So then the given expression, which was this, is perfectly equivalent to this over here, 1 over x squared, if x is positive. Because only positive real values for x were illegal up here. Therefore, only positive real values for x are legal down here. So we're not allowed to plug in x equals 0, certainly, but not even x equals -3 or -5. Now, I asked you way up here, what is the value of this expression if x equals 3? It's hard if you look at this, but if you look at the simplified form here, it's easier to plug into x here. All right, what is the value of this when x equals 3? It's going to be 1/9, right? 3 is a legal value for x. 3 is positive. You plug in 3 for x, you get 1/9. Piece of cake. So if you want to evaluate expressions, it's often in your interest to simplify an expression like that into a simpler expression in terms of x, and you can get this very quickly. There's a purpose to simplifying. Also, of course, in calculus, if you're asked to differentiate this or integrate this, you'd much rather do it to this guy here. Okay, simplifying is your friend, but sometimes it takes some work. All right, I have some footnotes for your side interest. Until then.